O nosso próximo palestrante é o doutorando Lars Orbach, da Universidade de Duisburg-Essen, na Alemanha, que é colaborador da professora Annemarie Fritz. O Lars vai falar para nós sobre a ansiedade e o desempenho em matemática. Eu imagino que ele vai apresentar resultados de uma pesquisa muito interessante, na qual ele aplica esse modelo de ansiedade traço e ansiedade estado no contexto da ansiedade matemática. Esse trabalho é originalíssimo, né? Já foi publicado, tem a referência na divulgação que a gente está colocando, e pela primeira vez foi desenvolvido um instrumento que permite diferenciar essas duas características da ansiedade matemática. Uma mais relacionada com a predisposição, com a diátese, a ansiedade, e a outra mais relacionada com os aspectos do desempenho. Aproveitam, divirtam-se, aprendam bastante, que o Lars tem muita coisa para ensinar.
Olá, muitos cumprimentos ao Brasil. I'm sending you warm welcomes from Cologne, my hometown, but my name is Lars Orbach and I'm from the University of Duisburg-Essen. And in the next 30 minutes I want to talk about math anxiety and about how anxiety affects the performance and also learning in general. Experience of anxiety is familiar to anyone, because it's a basic human emotion that protects us from danger. So when you're evaluating a situation as threatening and experience anxiety, you have three options. You can flee, you can fight, or you can freeze. And this is a very helpful situation when you're confronted with a tiger, that you have the physiological reaction that allows you to respond in an adequate way. But in a math situation, it's probably not the right way to flee or to freeze. So we have to think about why anxiety is such a problem in math. And in the development of children, you have different situations which evokes anxiety. And for school children, primary school children, many situations are school-related. One possible school-related stimuli can be math. And so the question is important to ask, what is math anxiety? This is a really important question because you cannot find clear definitions. You have a very hazy one in the literature, which tells you that anxiety appears in the confrontation with solving math tasks or are confronted with the manipulation of numbers in school and also in the ordinary life. But this definition has no clear criteria, so you cannot define it in a very clear way. And this is because you haven't got a classification in the DSM or the ECD, which are the classification systems for psychiatric disorders. But all the research has clear evidence that we have a specific phobia. So the math-related stimuli is a specific one which evokes specific anxiety reactions on a cognitive, on an affective, on a behavioral, and on the physiological level. Fundamental for the understanding of anxieties is the distinction between anxiety as a state and anxiety as a personality trait. State anxiety is understood as a temporary and situation-related anxiety reaction. So when this happens, your automatic nervous system has an increased arousal in the direct confrontation with math, as an example. Then you have an anxiety as a personality trait, which involves an acquired, relatively enduring anxiety disposition. And when you are confronted with a math situation in this model, which was developed by Spielberger, and some parts are appraisal theories by Lazarus, you have two appraisals which evaluate the situation. So you evaluate if the situation is relevant for you or challenging or a threat. And when it's a threat for you, you evaluate, have you the abilities or the resources to control the situation, to cope the situation. And when this is not the case, you feel state anxiety, and in this case, state math anxiety. For the research on math anxiety, this distinction is very, very crucial because we have different assessments to evaluate math anxiety. Many questions and questionnaires about the trait component are hypothetical or retrospective. So we have self-reports. How would you feel in such a situation? And there is something like an impact bias, because there are many stereotypes. And children and also adults evaluate their situation or their anxiety in a specific situation overestimated. So they think they have a lot of anxiety, but when you're asking them in the real situation, there's a huge discrepancy between the rating in the real situation and what they are rating in an hypothetical, retrospective self-report in a situation where they are not confronted with the stimuli which evokes anxiety. So when we report the results later on, there is also a differentiation between the state and the trait component, because the state component is a quite more valid one. Because of the assessment and definition problem, we haven't got clear data how often math anxiety occurs. But when we are comparing data of the PISA results, you can see on the self-report and on the trait disposition, probably Brazil has more trait anxiety than Germany or the OECD average. In general, we have clear and consistent findings for adults compared to very inconsistent findings in children. The reason for this, we have a research tradition of 60 years on adults, but only in the last decade more and more research was conducted with children. So in the next 20 minutes, I want to give you a good overview about the research on children. So it is quite trivial to talk about motivational and affective factors and state that they have an impact on school learning. In general, this is correct, but we are talking about the relationship of anxiety to math performance, and for a long time there was no clear evidence that this relationship exists. You have to take a closer look on the assessments, and then you can see that some trait assessments are not able to see such a relationship in the primary school grades. But state assessments and state assessments in different studies were able to see such a relationship between the state arousal in a math-specific situation and the math performance in this situation. So different math tests and different assessments of state anxiety, state math anxiety, were able to identify that state anxiety has a performance inhibiting effect on their math performance. But why are there impacts of anxiety on academic performance? Well, you remember the information on the basic information on anxiety at the beginning of my presentation. And probably you have some ideas why there are such performance inhibiting effects. In the literature and in the empirical research, you can have two major reasons for performance inhibiting effects. On the one hand, you have the specific behavioral anxiety reaction. The anxiety reaction you have in all different anxiety types. You will avoid the situation where you are confronted with your anxiety. So stimuli which evoke your anxiety, you have not the intention to see them or to are confronted with them. So you will avoid the situation. And in this case, you will avoid be in a math situation. So also in math situations like math homework or the general participation in lessons or the engagement in other situations where math is relevant. So this is one point and one aspect why are there performance inhibiting effects. The second one is clearly focused on the task processing in the math situation. So their typical impact on the task process and the problem solving in the math situation. Children, or also children and adults, so people who have an increased age, when they are confronted with a math task, some of their working memory is blocked when they are experiencing anxiety. So this resources or this capacity of working memory cannot be used for problem solving. So all resources you need for solving an addition task or a subtraction task or multiplication or division isn't there, or the resources are very, very few compared to a normal situation. And the reason is the attention focus. So where you put your attention is shifting from this task-oriented problem solving to the threat-related stimuli. So in other words, when you're confronted with a tiger, you will not looking at your map where you want to go. And in this case, the children who are confronted with a math task and they have anxiety, they will not do the addition tasks. They will think about what happens next. What is the consequence of failure? They have worries. They are probably distracted by the clicking of the clock because it's time pressure which comes into the play. And so we have an impact of their performance because their working efficiency isn't there anymore. They haven't got the motor to solve the task in a way they should or they probably could. In our research, we were able to see that not only state math anxiety is associated with lower math scores, we were able to see that the relationship cannot be explained by other anxiety types. Other anxiety types like test anxiety or social anxiety. So state math anxiety should be considered as a separate anxiety type, and a specific anxiety type like a specific phobia, which is able to have a specific effect on math performance. Well, another aspect is we can see that the anxiety, the math anxiety, has specific relationships to relatively enduring, also non-cognitive predictors of academic performance. So relatively enduring means for a longer time. So we have attitudes like learning motivation, which have also an impact on how children perform and participate in math lessons, as an example. And state math anxiety correlates with performance avoidance goals and work avoidance goals, and this in a positive way. So they have the tendency not only to avoid situations where they can show what they can, they are also avoid to work on math. And the other point is they are negatively related to mastery learning approach. So they haven't got the learning motivation to do and to improve their math skills. And this is very interesting. So children with a state arousal in math situations have also for a longer time attitudes which will impair their math performance and their math learning in other situations which are probably not so stress-invoking like exam situations. So to sum up, state math anxiety is not only an important influence in task processing and has a negative impact on task processing in math. It is also associated with attitudes which impact math learning under a long-term perspective. So state math anxiety influences in the situation and the learning behavior later on. And this is very important. And to come to the next question is, are all children in a similar way affected by state math anxiety? This is a quite difficult question when you take a micro perspective. When you take a broader perspective, it's very simple because every child is impacted by state math anxiety. It doesn't matter if they are very intelligent or have lower intelligence scores. All intelligence levels are roughly identically influenced by state MA. So also children with lower abilities have an impact of state math anxiety. On the other hand, when we take a closer look on the working memory, you can see that also there, all abilities show negative correlations to math performance. And not only for the broad type of working memory, you can find subtypes of executive functions, and I will come to this later on. But you at first have to know that all abilities in the executive functions show that children have a negative impact of state math anxiety. There's only one thing you have to keep in mind when we are talking about intelligence. We were able to see that there are low negative correlations between state math anxiety and intelligence scores. So some children with lower intelligence are probably experiencing more state MA. So probably there is a relationship which could be explained by the models of the appraisal. So children with lower intelligence scores probably evaluated situations as less controllable. So they have not the control belief to solve such a situation and therefore have more state MA. But in general, all children are roughly identical influenced by state MA. However, there was also a micro perspective on this issue, and when you remember that the attention system plays such an important role to explain how our anxiety impacts task processing, so there is a shift from the task processing to the threat-related stimuli by the attention system, and also there are blocked resources as a consequence of that. You have to know that we probably have to distinguish this attention system, and for that you need a definition of this attention system, and for that we need Miyagi. There are three different components of core executive functions, and they relate to different abilities. And the abilities are inhibition, cognitive flexibility, and working memory capacity or updating. And inhibition means that the individual has an ability to ignore dominant responses or information which are not necessary for task processing. And on the other hand, you have cognitive flexibility, so you can switch between different task components or tasks and also between different mental sets, so you can have a different perspective on the task. And on the other hand, there is the working memory or updating function, the ability to hold information in mind and to manipulate or work with it. So this is quite more related to which the most people understand under working memory. Well, to conclude, the model is very helpful to give us a more differentiated perspective on the relation of state anxiety to math achievement. So it gives us more precise information how different cognitive processes influence the negative impacts of math anxiety. Because we were able to identify that children with higher inhibition abilities are more affected by state math anxiety. And this is a very confusing information because children with the highest ability to ignore automatic or dominant responses information, which are not necessary for problem solving, they are more affected by state math anxiety. One possible explanation for this finding is children with high abilities, cognitive abilities, high working memory abilities, high core executive functions, they tend to use strategies to solve math problems which are very high demanding. So they use strategies which use a lot of resources, a lot of cognitive resources. And when they are in a situation where they have state anxiety, they cannot use their strategy anymore. And when they cannot use their strategy fluently, they probably make more failure and probably switch to less accurate strategies, and so their performance and their choking effect is quite large. And this is one explanation, and this leads us to new conclusions how we can prevent and elevate the effects of state anxiety. In case of students with high inhibition abilities, they probably rely longer on the more demanding strategies and inhibit signals which otherwise would lead them to other approaches which are less demanding, less working memory demanding, and would lead them to probably more success and less mistakes and less failure. Well, it's probably a good idea to sum up the latest results and latest conclusions. State math anxiety plays an important role in primary school children and affects not only their math performance in test situations, it has also an influence on their learning motivation and, because of their avoidance behavior, on the development of mathematical skills. So it's highly important to have a sensitive view on state anxieties in young children. The other point is we were able to see that all children are affected by state math anxiety. You cannot say that's only the case in children with high abilities or low abilities. No, all children are affected by state math anxiety. But we can see that there are cognitive processes which moderate this effect. And one possibility why children with high inhibition abilities, so the children who are good at inhibiting irrelevant information or responses, that they are so suffering under state anxieties, can be explained by their strategy choice and gives us new information how we could elevate state math anxieties in our students. In the last minutes of my presentation, I want to give you quick answers to very often asked questions about math anxiety. The one point is time pressure, and the other one is gender differences. You have to know time pressure plays an important role because stressful assessment situations caused by timed conditions evoke higher anxiety levels in children, and so probably less good performances. This is one point which we also see in our studies. Children evaluate their anxiety levels in time-pressured situations much higher after the math test. The other point is gender differences. 20 minutes ago, we talked about gender differences in adults, and there are clear gender differences existed. But now we are talking about young children, and probably you expected that we have inconsistent findings for primary school children. In our data, we were able to see that 3,000 students reported clear gender differences for state and trade math anxiety. But we need more research and especially more longitudinal research to develop a more comprehensive view on the early school grades and how math anxiety develops. Another point is, on the left side you can see a correlation table, and probably we have a different specificity of math anxiety effects on math performance. So probably boys have a specific effect and girls are more general impacted by anxiety, but all this needs more research. In the literature you can find different explanations why girls report higher anxiety. You have to know, in contrast to other psychiatric disorders, anxiety has a very high impact of environmental factors. We have a heritability, so a genetic influence by approximately 0.3. So there is a high impact of environmental factors, and so social stereotypes, self-concepts play a role, and as a consequence, there are greater willingness of girls to report emotional states. That are, at the moment, the main factors which are stated when we are discussing gender differences. In a more general view, you have to know why we are developing math anxiety, and here the research is at a very early stage, so we need a lot of more research, a lot of more longitudinal studies. But at the moment, we have different aspects which are a matter of discussion, and as an example, we are discussing how we react of negative experience with mathematics, so anxiety as a consequence of failure, and social environmental impact by parents or teachers which have math anxiety. We are talking about genetic risks, or probably wrong coping strategies when you are confronted with failure in math. And this leads us to our last subchapter of the presentation. What can we do against the impacts of math anxiety? Although the research does not provide so much valid information because the research tradition is not so old, you can see on the last two slides that there are many ideas how to improve or to modify school teaching. On basis of our research, it is possibly very helpful to change the framework of exams, so less time pressure and less distractors. So possibly these are ideas out of the ADHD teaching and ADHD learning, where you have a very structured way to deal with such a problem. Here, it is possibly helpful to structure math tasks very clear so that the attention can be very good focused. Besides all the other very helpful remarks, like supporting self-efficacy, I would like to highlight one very important point, and this is based on our data, on the core executive functions, and also by a new study by Pasalungi. We have to take a closer look at the strategy use of children. We have to provide a learning environment where the children are able to practice their strategy use and to practice their strategy use in a way it is not so demanded on the working memory resources, so it has to be very fluently. And this is supported by the findings by Pasalungi because she did the first intervention study on math anxiety, and she was able to identify two different interventions which are very helpful. On the one hand, which is not so surprisingly, emotion regulation training, and on the other hand, the math strategy training. So as a teacher, in primary school, it would be very helpful to give the children a lot of space to practice their strategy use and to use their strategies for very different math tests and in very different situations so that they can adapt them. And when they are very fluently in that, they probably could provide the negative impacts of math anxiety. Well, thank you very much for your attention. I hope you enjoyed the presentation and you have some ideas how you could handle math anxiety in your class. I want to finish my talk with the best wishes and also the wish of healthiness in these special times. And well, we are thinking about Brazil a lot, and we have a lot of newspaper articles about it, and we hope that everything will be fine in the next months or years. Bye.